So what if an AI could learn just like a pro athlete, by watching game tape of their greatest plays over and over again? Imagine it creating its own personal highlight reel and just relentlessly studying that to get even better. Well, that's the core idea we're going to dive into today.
And this whole concept has a name, SPEAR. Now, the full name is a bit of a mouthful: Self-imitation with Progressive Exploration for Agentic Reinforcement Learning. But don't worry about that. The key ideas are right there: self-imitation and exploration. We're about to unpack how this new method teaches AI agents to learn from their own successes.
Okay, so to really get why SPEAR is such a big deal, we need to talk about a fundamental problem that every single learning AI agent has to deal with. It's this classic dilemma: when should I try something new versus when should I just stick with what I know works?
This whole dilemma really boils down to two choices. On one side, you've got exploration, trying new things, experimenting, hoping you stumble across a better way to do something. And on the other side, you've got exploitation, which is all about perfecting a strategy you already know is good. Go too far one way and the AI gets stuck, too far the other way and it never masters anything. Finding that perfect balance, that's the whole game.
And just so we're all on the same page, when we say agent, this is what we're talking about. It's not your average chatbot. This is an AI that can actually use tools. It can search the web, write and run code, navigate a website to get complex jobs done all by itself. Think of it like a truly autonomous digital assistant. Now, this balancing act is so tricky that researchers actually have a way to measure it. They use a concept called entropy. You can think of entropy as just a measure of how unpredictable the agent's strategy is. If there's too little entropy, it's boring and predictable. If there's too much, it's just pure chaos. The goal is to walk right down the middle of that tightrope.
See, if the agent exploits too much and stops exploring, its entropy collapses. It finds one halfway decent solution and gets way too confident, just doing that same thing over and over. It gets completely stuck in a rut, and it never finds that potentially brilliant strategy that's waiting just around the corner.
But if the agent explores too much, you get the opposite problem: runaway divergence. Its entropy just spirals out of control. It becomes so chaotic, trying so many random things, that it can't actually learn anything from its actions. It never settles down to form a stable winning strategy.
So how in the world do you walk this tightrope? Well, this is exactly where SPEAR comes in. It offers a really elegant new philosophy for training these agents, one that helps them learn from their wins without falling into either one of those traps.
And the philosophy behind it is so simple and intuitive. Learn the ropes, then trust the wins. First, you let the agent just mess around and explore, figuring out the basics of the task and its tools. Then, once it starts to have a little success, it learns to zero in on what's actually working.
The secret sauce here is a technique called self-imitation learning, or SIL. The way it works is it creates something called a replay buffer. And you can think of this, literally, as the agent's highlight reel. It stores only the agent's very best, most successful past attempts, and then the agent studies that reel to guide what it does next. It is literally learning from its own greatest hits.
So how does SPEAR actually put this all together into a practical playbook? It uses this really clever curriculum that is designed specifically to avoid those entropy traps we were just talking about. The whole process is broken down into two crucial stages. In step one, it's all about broad, skill-level exploration. The agent gets rewarded just for trying its tools, not necessarily for succeeding. This is the learn the ropes phase. Then, in step two, the focus totally shifts. The agent starts studying that replay buffer of its successes to perfect its winning strategies. And that's trusting the wins.
Now, to keep this whole process from going off the rails, SPEAR has 3 really clever tricks up its sleeve. First is advantage recalibration. This basically updates the value of old wins so that an early, easy success doesn't look useless to the now smarter agent. Second, there's a curriculum schedule. This slowly dials up the self-imitation, so the agent doesn't get obsessed with some simple win it found way back at the beginning. And finally, something called covariance clipping acts like a guardrail, stopping the agent from becoming too confident in just one strategy. It makes sure it stays a little curious. Okay, that all sounds fantastic in theory, right? But does it actually work in practice? Well, the researchers put SPEAR to the test on some seriously challenging tasks.
And the results? They weren't just good, they were a total game changer. On the web shop benchmark, which is a task where an AI has to navigate an online store to buy a specific thing, adding SPEAR boosted the success rate by a massive 20.7%.
Let's put that in perspective. Look at this. The
The baseline method, GRPO, it succeeded about 57% of the time. You know, not bad. But when you add Spear to it, that number skyrockets to 77.5%. And what's really amazing is that it didn't just improve the baseline, it made even stronger methods better too. This proves it's a really versatile kind of plug-and-play improvement.
So, why does any of this matter? Well, a more effective training method means we can build smarter, more reliable AI agents. And this isn't just about getting higher scores on some academic benchmark. It's about creating genuinely better tools for all of us.
So what's the big picture here? Well, Spear gives us a more stable, efficient, and scalable way to train capable AI agents. And because the agent is learning from itself, we don't need these massive, really expensive data sets of human examples. This is a huge step toward creating reliable, maybe even creative, AI partners that can help us with really complex digital tasks.
And all this leaves us with a really fascinating final thought. As these agents get better and better at learning from their own wins, mastering tasks we can barely even imagine today, what completely new problems are they going to be able to solve for us in the future?